Chapter 13 Solutions. Exercise 13.53. An aqueous sodium chloride solution is made using 127 grams of sodium chloride diluted to a total solution volume of 1.30 liters. What's the molarity of this solution in mole per liter? So we'll have to have mole on top, which is 127, divided by the molar mass of sodium chloride. Sodium is 22.99 and chlorine is 35.45. Now we have the number of moles of sodium chloride and then divided by 1.3 liters. This is how we set up the calculation. Part B. Calculate the molality of the solution. Here, this is molality. It's in mole per kilogram. And this is referring to the mass of the solvent only, not including the solute. In this case, it's just the mass of water. Still, we'll have to compute the number of moles of the solute. This is the number of moles of the solute. So I'm going to put this in a pair of parentheses. This is the number of moles of sodium chloride. Now divided by the mass of water. How do we get the mass of water? We have the density of the solution, we have the volume of the solution, so we'll be able to get the mass of the solution. And don't forget to subtract the mass of the solute, 127 grams. Alright, so we'll do that. We have the density 1.08 grams per milliliter times 1300 milliliters. I'm converting liters to milliliters, and then minus 127 grams. We have now the mass of water in grams. I'm converting that to kilograms. Just to be clear, I put everything on the bottom inside a pair of parentheses. Again, on top you have the moles of the solute. Bottom you have the mass of the solvent in kilograms. You can see the molality is fairly close to molarity. This is just because when you have an aqueous solution, usually if you have 1 liter aqueous solution, it contains roughly 1 kilogram of water. Part C. Calculate the mass percent of the solution. This is pretty easy. So we have the mass percent of the solution. We need the mass of sodium chloride divided by the total mass of the solution, which is just 1.08, the density, and then times the milliliters. This is percentage, so we'll have to do this to convert this number to a percentage. It's roughly 9%.